Hi everyone, welcome back. So today's concept is going to be on inserting a node at front in singly linked list. So how do we insert node in a singly linked list, which means inserting a node at the beginning of all the nodes. So assuming that we already know how to create a singly linked list, if you see the previous video of mine, you will understand how to create a singly linked list. The same example node I had created here. Now there are three nodes with the data 10, 20 and 30, which means you have two parts here, data node and the link part, data part and the link part. So the first node is created at address 1000, second node at address 2000, third node at address 3000. Now what we are going to do, we are going to insert another new node before the first node. So this is the concept. So let me write a small function here, void insert at front, which means front is before the first node. Okay, before the head node. Okay, so now we have to create one more pointer variable, struct node star temp. Now temp is also of the structure node, which means again temp will have two parts, data part and link part. Just like the previous node, the temp head node that we created, each and everything will add two parts, data and link. Similarly, we are using the same self-referential structure in order to create another new node. So now the node name, it is pointed by temp pointer. The new node is named with temp pointer. Fine. Okay, now we have to allocate memory space in order to add content to the node. Okay, so what is the syntax? Temp is equal to, using dynamic memory allocation malloc of size of struct space node. After this sentence, after this statement, temp will be allocated with some address, memory address. Assume it is at address 4000. At address 4000, temp has been created. Okay, now we have to add data into the newly created node. So how do we add? Print function enter value of new node, scanf %d. So we need to store, right? So I write int value. I'm using another variable called value. So value initially it has nothing. Okay, address of value. After these two statements, when value entered is 40, okay, 40 should be stored inside the newly created node. How do we do that? Using the arrow operator. Fine. Temp pointing to data is equal to value. So what is value? 40. 40 will be stored where? Temp pointing to data. So 40 is stored here. Got it? Okay. Now after adding the value, what we have to do? We have to insert the newly created node at the beginning of the first node, which means, see how we have linked here, the second node is linked with the address 2000, which means the link part will have address of the second node. Here the link part of the second node will have address of the third node. Similarly, if I have to insert this at the beginning, the link part of the temp node should have address of the first node. What is the address of the first node? It is 1000. So head is pointed at address 1000. So what is the code here? Temp pointing to link. Temp pointing to link should have 1000, right? So temp pointing to link is equal to head. 1000 is at pointer head. So temp pointing to link is equal to head. Got it? Now, which means link part has the value 1000, which means we have created a link from temp node to the head node. Now we have inserted, before 10 we have inserted the value 40 dynamically. Understood? Okay, now what did I tell you? In order to hold the reference of the head first node, the head pointer should always point to the first node. So we have to move head node to the first node here, because now head is pointing to the second node. So we have to move. What is the code? Head is equal to temp. What was temp value here? After this statement, it was 4000, right? It was 4000. Now head is equal to temp, which means head value from 1000 would have been replaced with 4000, which means from here head will move to the newly created node. Okay, that's it. Now later if we print the value using the traversal, node traversal, we would get the output as 40, 10, 20 and 30. So this is the output. Okay, I hope you understood the concept. Thank you.